is going on, guys? Welcome back to the channel or channels. Not really sure what one you guys are going to be watching this on, because I may take you guys on a daily vlog. I'm thinking I might try that, where I'll upload to the Avenged channel, which is more so the buggies and custom fabrication and that stuff, but probably do like a daily grind type vlog show, so I can just bring you along on my daily small business kind of activities as well, along with the buggies and whatnot. Or the Exquisite Metalworks channel. I'll link two of them down below, where you're probably just going to see more of the metalwork and business side of things. So it is Monday evening, of course, and pretty self-explanatory because it is Monday. I planned on making this video or starting this video Monday morning, but it's now Monday evening, and I finally got back to the shop and finally get situated. I get a phone call, and I kind of have to move a few things around here so we can get at my deck over trailer, hook it to the truck. I actually made these floating stair stringers for a customer last week, and he actually wanted to take those, prep them himself and paint it. Called me a couple hours ago and asked if I could take those and bring them up to the local sandblast and paint shop. I said, yeah, no sweat, man, I'll give you a hand for sure. So what we're gonna do, we're gonna jump on the forklift, move some things around so I can get at my deck over. There is some material on the deck over that I might just hand bomb off. I don't know, we'll see. We're gonna have to play it by ear, move some things around, and let's just hit it. guys, it is actually the next day, and I dropped those stair stringers off to the local blast and paint shop to get blasted and painted, hence the name. And that should be going to the customer, and he's going to install that wherever it has to go. Now this machine here, every time my girlfriend walks by this thing, she starts to hyperventilate. And I can only assume it's because in her mind, she's thinking about the vast amount of sourdough bread she can shove through this thing. Either that, she's just annoyed looking at it amongst the other, what she calls junk out in the yard. I guess we'll never know. I guess we'll never know.
All right then, keep your secrets.
Rest assured, ladies, that's not what this is. This is actually a sheet metal roller. So if you ever wanted to know how they roll snowplows or oil tanks or septic tanks or bottoms of excavator buckets and a whole bunch of other different things, usually it's a machine like this. Now the cool thing about this machine is that this was actually made quite possibly before my time. And I think that makes it cool. Now, unfortunately, it doesn't have all the fancy technologies like CNC and hydraulics and whatnot, like the new ones do, but it gets the job done. Now, this one here, of course, unfortunately, has to live its life outside, which I hate because I am very low on shop space and yard space and space. So like I said, guys, we will dive into this quite a bit more drastically on another video. But this is a 3-speed gearbox, I think out of some sort of marine-based application perhaps, driven by this 220 powered motor. As you can see, it's belt driven, but it's all gear drive that drives our pieces of pipe. I assume that's what they are. I don't think they're solid. It's not that heavy. So I believe it's pieces of pipe with ends welded into them. Then they machine some type of shaft, stub shaft, and they actually done a really good job because they made these grease manifolds, grease hoses to every bearing point, and you can actually grease this thing. That's just angle. As you can see, this was all flame torch cut. I'm sure these little slots and whatnot have a story of itself. I have no idea what they do. A very, very rudimentary way to roll plate. Another thing that's actually pretty cool on this one is that these are actually just pins. So if you were rolling a piece of plate and you had to do a perfect circle, what you would do, you would roll the whole circle or at the diameter you need, whether it be sheet plate, take these pins out, lift this end off, and then you can slide that piece out. So newer machines, of course, are all hydraulically controlled, hydraulically driven, and quite a bit more expensive, probably like 18 times more than what this thing cost me. Now the only issue is that I have with it is that it's kind of slow. You're not going to put a piece of quarter plate through here and get it on the first roll. So what I have to do, I have to put the plate in, let it roll through, do its thing, crank these down, what I can get on them, let it roll back the other way. And that's how they have this dual switch onto it. So essentially this reverses the motor. You hit this one way, it's forward, reverse, and that's how you're back and forth. We also have a few leaks, of course, in around these seals, but that's just the universe's sight glass. Essentially, if you have no gearbox oil coming in around the seal, you're probably low a quart, so throw a quart in there. It's the universe telling you you're low. So pretty cool design. Thanks, universe, I think. So now, even though this is called a sheet metal roller, I'm actually after rolling quite a bit of square tubing through there. And this local farmer actually reached out and he brought me this. So this is actually a pile of tetanus at the moment. But at one part of his life, I think it was one of those things that it's a kind of a feeding corral for livestock. You put one of those big marshmallow hay bales in the center. It has different sections, I guess, for the animals to put their heads in to feed off the hay. He asked if I could just roll him some square tubing so he can make the rest himself. Essentially, he got some bars or something down there, I believe he said. He got his own little welder, and he's going to try to weld it together himself, and I'm perfectly fine with that. So as you can see, we got our bandsaw loaded up. Super small shop space, so we kind of got to get creative. But this is a full length of 1x1 square HSS. I believe it's around 120 wall. And I have it marked at 16 feet overall. That should get us close enough where it's a little bit of green on the end. We have an overall length of 16 feet. I'm actually gonna come in here and mark center because I'm actually gonna cut these in half for the customer. We're gonna do a full roll and then I'll just cut it in half and then it'll just have a couple different sections as opposed to just full circles that he'll have to cut. That's what I like to call good planning, AKA learning from your mistakes. So unfortunately, we had to go outside because I just didn't have the ceiling height. Now realistically, I could have cut it in half and kind of rolled 2 pieces at once, but I kind of wanted to get a perfect kind of circle as close as we could and then just cut it in half. I think that would be the better way to do this. But unfortunately, we have a beautiful spring day in Newfoundland, as you can see, but I think we'll get it. We'll win. I'm not letting it win. We're gonna win. Check this out. We have got a circle out of 1x1 square tubing. There's a couple little flat spots and I think I messed up because if you look very closely here on square tubing and on some round tubing, you actually have a welded seam. I usually like to have that welded seam either up or down. On this one, I put it on the side. I actually have another 5 of these to make, so I'm not going to bore you with all that. I'm just going to bang them out and I'll see you when they're done. That's going to be a wrap on our livestock feeder rings, I guess we will call them. I'm just going to cut them in half for the customer and he can come get them at his leisure whenever he sees fit, I guess. As for our slip roll or sheet metal roller or sourdough roller on steroids, you'll be seeing that back in the shop here sooner than later. I actually have kind of this art type job that's coming up that I'm going to need that for, but I need to modify it for said job. So I need to get that in here, kind of take it apart and kind of modify it for my needs. I always did want to modify it a little touch anyway, so this is kind of just an excuse to get me in the mindset to do that. Once again, I don't really know the age of that thing. I don't know how much plate is actually ever rolled through there. I have no idea the history on it. So it's time for kind of like a refit and a restore more than anything anyways. As I was rolling those rings, I seen a little bit of like loose bushings and whatnot. So it's definitely time to give it a little bit of love. So with all that being said, let's jump on to the next thing. All right, so next up on the list is this handrail or pieces of what's going to be a handrail. This one's a little bit more unique than other handrails, and we'll dive into that in a second, what kind of makes this one a little bit more challenging. First, we'll go over the material list. On the bottom one, we're going to call this the bottom mounting flange or the bottom rail of our handrail. This is actually 5/8 thick, solid, mild steel by 3 inches in width. This other one, this is going to be the main top rail. This one is roughly 3/4, I believe, and 2.75 in width. That's going to achieve the look when you look down straight on top of the handrail. You're actually going to have an 1/8 of an inch reveal from the top rail to the bottom rail. Now these two pieces here, they're just going to be the end pieces. One goes there, one goes there. This side here goes against the wall. That side there is kind of open-ended. You'll just kind of come up over the stairs and you'll see one of these. As for balusters, every 4.5 inches along these rails. This is what they call 3/4 round stock, bar stock, solid stock. It's not pipe, it's not tubing, it's solid. And that's going to go every 4.5 inches over 13 feet. So this rail is going to be quite heavy. Now the biggest difference with all this is going to be is that usually when you do a interior handrail, you're usually working with a woodworker. So you'll make a couple mounting flange like this. He'll come in afterwards and he'll put a nice rounded or profiled stained piece of wood on the top, and that will be your handrail. This one, the customer wants 110% all steel. So that means in my post cleanup, when I'm doing all this, I got to make sure all these edges are kind of rounded so you don't grab your finger and you don't get cut. Essentially, when you're working with metal, when you CNC cut, when you shear, when you kind of do anything, it leaves a sharp edge. And a lot of times that sharp edge will actually cut you. So I need to make sure that all this is kind of rounded and smooth, but I also need to make sure it's all uniform, because once again, if you look down and you're kind of wavy on your grinder, you're going to catch that with your eye. Now, the reason I think they went 5/8 on the bottom is I believe that they actually have 5/8 hardwood that will come in and just butt up against that, bullnose in, and everything will be nice and level when you're looking across your floor. Now, the main challenge here is that they don't want to see any welds. This kind of complicates it, but kind of not. It just adds a little bit more work in your post cleanup. The bottom one, of course, I'm going to come in with my mag drill and I'll just drill directly through this 5/8 piece of plate. Then that way I'll take my 3/4 round, slide it down those holes, and I can actually weld underneath. Now, that's not an issue here on the bottom because that's actually going to be mounted to the floor itself. You'll never see those welds ever again. As for the top, where this is going to be in the stairwell, you're kind of walking up your stairs here. They don't want to see any welds when you look up. They don't want to see the weld here on the bottom of their handrail. What I've kind of come up with is that I'm going to end up having to either, one, drill these holes all the way through, putting these up and welding on the top. But the issue with that is that if I bring that up all the way, I almost need to prep every one of these so I can get some weld down there and get some penetration down there. Because if I were just going to go flat to flat and then do kind of like a butt weld, then I had to come once again and make sure all that's flat with some sort of buffing wheel or my rotary buffer. You're not leaving a lot of meat. And where this is a handrail, it could possibly kind of twist on this little piece, could actually get a crack in your weld because you've left very little weld there. Now, another way I was thinking that I could possibly do with this top rail is probably drill into this 3/8 of an inch. So then our 3/4 round will sit 3/8 of an inch into our top rail. Then finish that hole with probably a 1/4 inch bit, 3/16 bits, something like that. And then come along and just plug weld on top. Then that way you got a little bit more meat to kind of weld to and kind of get a plug weld in there. Maybe that'll be less grinding and it'll be a little bit stronger. So I'm still up in the air about that. I'm still not sure if I'm going to come in here and just kind of chamfer that off, because I think if I do it with the 3/8, that's going to keep everything way more uniform and tight fitting in the fit up process. But if I'm going to come in here and just drill every hole at 3/4 and then have this chamfered off, that could have a possibility to kind of twist and warp a little bit. So I'm kind of leaning more so the 2 drill bit system, but I haven't really got there yet in my brain, but I will figure it out. With all that being said, we're going to act like Johnny Sins and drill a bunch of holes.
A few moments later.
So for all intents and purposes, we are finished with the 3/4 holes on our bottom rail mounting flange, if you want to call it that. Now I do have to come back in here and actually create mounting holes every so often. I need to check out the drawing on that and see where they want them exactly. Now the client or the engineer or the architect, I would assume the engineer, kind of wants to use these type of screws to hold this thing down. I'm not really sure of the rating on these, but that's what he dropped off for me to kind of go by. Now, I'm going to have to either come in here and drill a pilot hole when the time comes, or drill a little bit larger hole. I'm not really sure on this one yet, but we will cross that bridge when we get there. Now, the issue we're going to run into here is that this one, hopefully I can get you in there close enough, actually has this shoulder on there that kind of goes down and kind of centers everything up. It also has this little bit of a lip. So I'm going to have to countersink a bit because, of course, they want all those to be flush, like you would. Now, that's that one. I have to tip that one back over, clean that up. I also want to come in here and break this edge here, because this is the one that actually is kind of in your face as you're walking up the stairwell. As for this one in here, well, that's where your hardwood floor is going to butt up against. So this one here doesn't really matter. This one here doesn't really matter. It kind of got to be tight with the hardwood. This one here, that's one that's going to be kind of right here as you're walking upstairs, and well, the bottom one's going to be on the floor. The other thing that may be a little bit of a hiccup is, well, when you're painting something or powder coating something or coating anything in general, You don't want a super sharp edge because that super sharp edge is very little material for any paint or powder or sealant or anything to kind of catch to. So with this being as sharp as it is, it might be prone to chipping, but I'm unsure because once again, it's industrial paint. It's going to just be in kind of an area with low traffic because it's just a handrail. It's not like it's in a mall or something, so it might be totally fine. But for that, I think we are going to be done with this one just for a little bit. I'm going to jump on to the next one, but I think I might as well run you guys through a mag drill because maybe some of you guys haven't seen a mag drill or understand how they work, but I will just run you guys through it a little bit because this is where I'm thinking my next chain of events is going to have to happen, and I'm going to have to kind of be particular on this one, I think. So a mag drill is exactly in the name. It comes with this magnetic base, sticks, and well, it's a drill. I actually started drilling all these holes and I forgot that I had an auto feed on this one, so that's pretty cool. So let's go over the drill bits themselves because this is where it differs. Now, of course, you can get an attachment, which I believe I do have, regular drill bits in the mag drill. But the downfall with this mag drill is that it's just set to kill. There's no adjustment on speed, so it's kill all drill bit mode, and it does it very well. So if you have a very small or finite drill bit, you got to be very careful because it will snap it off in a jiffy. So let's talk about the bits. Now, of course, this is your regular drill bit. As you can see, we have these deep flutes. That's how that material makes its way out of the hole as it's drilling. And where the flutes meet here, this is your center point, and that's kind of how you center that drill bit. Now, when it comes to a mag drill or an annular cutter, annular cutter?
Well, he don't know talking good like me and you.
As you can see, we have a little bit of a gap here. Now, the cool thing about these, they actually come with a center pin. So this is where this gap comes in. Now, what this actually creates as it's drilling is known as a slug. So when you're actually drilling this hole, that center pin there centers your center punch, keeps everything centered. And as it's drilling, well, that slug gets created like that. And of course, this is the back of that material that gets popped out. Now, this is actually spring loaded. So as you're drilling, this actually kind of gets recessed up into the drill. Then this center slug, essentially, the theory is it's supposed to pop out once the job is done, and it pops on the floor and it's over there in the corner somewhere. But with heat and a little bit of debris, it actually gets stuck in there. So sometimes you have to give it a little bit of love and give it a few love taps to get them to come out. Now, this is where my issue kind of arises because, like I said previously, our 3/4 round stock, round bar, has to sit here and be welded on the back side. Now on the top one, it has to come up, and I'm going to have to drill a smaller hole to plug weld. So I want this to come up inside to get this nice tight looking fit here. As you can see, this is really nice tight tolerance. But on this one, they want that exact same kind of tolerance to it, but they want it welded on top of the handrail. So I think I'm going to kind of come up with some sort of hard stop for this while I'm drilling. And that's only going to come up this 3/4 plate, probably 3/8. And then I'm going to come along with my quarter bit and drill. And then I will have a 1/4 inch plug weld, which it will attach this 3/4 round bar to this 3/4 flat bar, I guess we can call it now, but it's the top handrail. The issue with that is I kind of messed up in CAD. I never really took it into account. I never thought far enough ahead that I have the center punches on top of the handrail. Now, this is the issue because, like I just said, your centering pin gets kind of taken out with a larger drill bit, and I don't want the 3/4 hole on top. I want it on bottom. So I'm thinking if I drill on the bottom 3/8, then I change to my 1/4 and drill the rest of the way, I'm still going to maintain my center point because that slug should still be within the material. It shouldn't be drilled out because I'm only drilling halfway or a little better than halfway. So then when I change to my 1/4, that center hole or center punch theoretically should still be there, and then I will drill all that out. That's what I'm thinking. I've never tried it before, but I guess we gotta try it. The only other option is I take this drill bit's life in my hands, which is the same diameter as our center pin, drill a pilot hole through everything, and then do exactly like I just said, and our pilot hole will be there for our center pin of our annular cutter. Once again, the issue is that I put all these center punches on top, so I think I'm gonna have to flip all this over, flip this over, and transfer all the holes on the back side of our top handrail, so that way I can start drilling through the underside. I have it flipped over, guys. The top rail is actually on the bottom. This is the bottom rail that we just drilled. So I'm going to transfer the holes now. We have our 1/8 offset all the way around, which I have checked with our square. We have set up at 1/8. So how we're going to transfer these holes, this is our 3/4 annular bit. We're going to pop that in here. And instead of using our centering pin for those bits, which I don't believe are actually hardened, they're just, like you say, just to center those annular bits, I'm going to use a center punch, which is actually the same diameter as the centering pin. Drop that down there, and that's how we're going to get the center of our hole. So what I've actually done here, guys, is I grabbed a piece of 3/16 scrap steel I've had kicking around, laid my mag drill on top of our flat bar, our top rail. This is actually the bottom of our top rail, and just use this kind of as a guide. So I'll have 3/16 of material to plug weld to when the time comes, and this is a depth that we're going to drill our 3/4 hole, and that 3/4 hole will then accept our 3/4 round stock and keep everything in line. Then when we flip this over, well, we'll have I believe a 1/2 inch by 3/16 depth hole to plug weld to. Now I've been saying this here is 3/4, this top rail. It's actually 1/2 inch, so that's my bad on that. I've been saying the whole duration of this video that it's 3/4, but it is 1/2 inch. So what I actually want to do now, I want to actually create a hard stop between here and here. So there's 29 holes in this thing. So I want to be able to make sure that all those holes are the exact same depth. So what we'll do, I'll just grab just get it rough. We don't have to be dead on here. Oh, we're outside. There you go. So we're at roughly 1 inch, if you guys can see it there. And once again, we don't have to be dead on here. Calipers are probably not even needed for this measuring tool, but that's what we're using. So 1 inch, I mean, if we went and grabbed some 1 inch square hollow HSS, there's our hard stop. So I'll just take that when I come up here, solid on our stroke of our drill. We know that we should have 3/16 material left over on the top side, which is the back side, this is the bottom side of the top rail. Clear as mud. I guess we may as well, try one. Work on this one. I forgot to wear my spectacles, which you should always wear your glasses with this. Now the reason I don't wear gloves with this is because this thing is spinning around and this isn't going to let go of a glove. So there was actually quite a few years ago, I believe I was on a job site, and there was a lady actually drilling a bunch of holes similar to what we're doing today, and it grabbed her glove and it actually wrapped in around. There's so much torque in here that it's not stopping. It will do a lot of damage. So I'd rather not wear gloves on rotating assemblies. Sue me. So this is what I'm thinking my theory is here. As you can see, the center punch is still there from our 3/4 hole. So if I come in with a 1/4 bit, I could still utilize that center punch to center this 1/4 bit, and I should be able to continue through and have a quarter hole on the back side for the plug weld. Haven't really tried it before. This is the first initial test hole I've tried this, so I'm going to bring you guys along with me. If this does work out, I'm not going to keep swapping back and forth. What I'll do, I'll just end up drilling the whole rail at this 3/4 with our 1-inch hard stop, and then come back and just drill the remainder 1/4 hole. So that worked out pretty good. I'm happy with that. I'm going to continue on that path, I think. You can see, it's kind of hard to see on camera, but there's actually a nice little shoulder there now to plug weld to. A little bit of meat there, but I'm happy with that, I think. I think I'll call that good. So I'll continue on that path, keep drilling all these 3/4 first, then come back over it and drill the 1/4. It is actually the next day, guys, and the first thing I had to do this morning was run and get a couple more pieces of bar stock. See, I got all those cut them with our good old bandsaw, took them and knocked the edge off with our sander here. I'm not saying I can make your fingerprints disappear, but if you ever need to get away with something, you know, just hit my DMs up. I can probably make something happen. Not saying it's not going to be painful, but it can happen. So what I actually done first thing after I installed all those bars, I came in here and figured out our mounting holes. Now I actually done this in 3 steps, so let me just set you up there and I can give you a quick explanation. So guys, this right here is going to be our mounting hole. Now I actually had to do this in 3 different steps because this is the screw they actually want to utilize to screw this thing down. Now, as you can see here, it actually has a shoulder and a little bit of contour here. So I actually had to do this in 3 separate steps to get that to sit flush as possible and also to get the most surface area to bite in here. Realistically, you probably could have just made quite drastically a large hole and just let this ridge kind of hold that down, but I wanted to get the max amount of bite force or surface area on that as possible. So what I actually done, I had to come in here with our annular 3/4 and actually drill down to this depth here. That gives us our little bit of resection down into our steel. Then I actually drilled the main hole, which is the same diameter as our lag bolt or screw or mounting hardware, we can call it. Then I actually came in here with what's called a chamfering bit and actually put that little bit of a ridge on there. So this contour here or wedge will actually fit really nice and give it the most amount of surface area possible. So I think that came out good, at least with what I have available at my fingertips. I'm sure there's probably, you know, one singular bit out there that does all that. I'm not really sure, but for what I have here in the shop, it came out okay. Let me just clean you up there, you know, because you're a little dusty, guys. Guys, this is pretty much the finished handrail. I still got a little bit of buffing that I want to do here. There's a couple sharp edges here on the bottom I really like to take care of. I believe I do have a little bit of an arc strike where I have my ground clamp for the welding portion of the whole thing, but it wasn't too bad. Essentially all I done to get this together, I was supposed to have you guys on time lapse, but I forgot to hit record. What I done, I just took 2 straps and kind of just moved along as I was going. Now, don't get me wrong, it did take, you know, a little bit of persuasion, but here's our rail. So, with all that being said, I'm going to show you guys the plug welds. So this right here is essentially the final result. Once again, I do have a little bit of buffing that I would like to keep going with, but this is what I was saying, like where it's so sharp here on the edges. As you can see now, we can't see any welds, top or bottom. Came out pretty good. I also didn't weld inside here because I assume if they don't want to see welds there, they're not going to want to see welds there on this end piece. That's my assumption, but you know what assumption gets you. Now, I'm not really sure. I never seen any details or specifications on what they're going to do with the blast and paint aspect of this, because it's kind of in you to kind of try to get this line out with your buffing with a grinder. But the issue with that is that if you go in after that, usually you will have like a hollow, and that's not a good thing. But for the most part, I think this came out pretty good. There might be a little bit of low. But what I'm trying to say is, if they plan on just taking this, blasting it, and painting it, you need to have that as uniform as possible along that top rail. But if the painter is actually going to take a little bit of, I don't know, fiberglass or polybond or auto body filler and kind of go across there, it doesn't really matter if you do have a little bit of low. Actually, it's probably preferred that they were a little bit low if they were actually going to do that. But I might have to make a phone call on that. But for the most part, I'm happy with how it came out. This is a nice rail. I could definitely lean against this all day and watch someone work. Excellent, excellent rail. A little bit heavy. I feel kind of bad for the guys that have to install it and move it around because, oh man. But yeah, that's for them to worry about, and my job is almost complete. As for the next episode, you're going to see that single axle trailer probably come out. We're going to have to flip that over, take the old axle out and put a new axle in there. Bunch of mobile work coming up. I believe there's a sailboat with a stuck bolt. I'm going to have to go there and get kind of creative. There's a tongue on another trailer that needs mobile work. I believe there's some sort of forklift ramp as well. There's quite a bit of work coming up in the future. You'll see more of the UTV stuff that I'm kind of behind on as well. With all that being said, if you got this far, I do appreciate you. Keep grinding out there, guys. I'm right in the trenches with you. I'll see you on the next one.